Hi, class. Okay, so we have finished chapter 1. Okay, now let's go to chapter 2. Yes.
So we have a question from
Pardon me?
have a question
You have a question?
from Steve. Yes.
Oh, okay.
It's regarding the
Assignment, yeah.
it's the question with the cards,
The cards.
the module make module. Page 25. I think.
The categorical data and quantitative data.
Okay. So it's it's uh it's how many variables are in the data set?
Oh, question 25.
Question 9.
Question 9. Uh, question 9C or,
Sorry.
oh, that's question 9. Oh, okay. How many variables?
Right. So
Uh-huh.
we were a bit confused with the what is the element make model? Why is it important there? Maybe you just
The make.
the make of the element, right?
Uh,
Or
oh, okay. I I think it is an element, and then um, the second starting from the second column, model overall score, recommended, owner satisfaction, overall kilometers per liter, acceleration. Those are variables. Make and model.
it's considered the elements.
Oh, make and model are the element. Two of them. Oh. Both are elements. Oh. So she said that there are 30 elements, or yeah, 15 elements. Yeah, 15. Oh, only, oh, starting from the overall score. Hmm. Okay. Let me think of that, and I will get back to you later. Okay. 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 So only so you have question about the number of variables and elements. Oh. 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 Okay. Thank you. Okay, I will get back to you later. Okay. Now let's go to chapter 2. Um, okay, so usually after we collect data, we would like to use tables or charts to display the data. Okay, and okay, so for the table, okay, there are some forms of the table we are using, and also the charts. Okay, but some of them are used for categorical data. Some of them are used for the quantitative data. Okay, and after that, we use the descriptive statistics. Okay, now let's see how to summarize for a categorical variable. Okay, so usually, what is the categorical data? Okay, in the categorical data, we use labels or names to identify categories of identical items. Okay, but for a quantitative variable, okay, we use numerical values that indicate how much or how many. Okay, so that's the difference between categorical variable and quantitative data. Okay, so again, for categorical data, we use labels or names. For the quantitative data, okay, we use the numerical values, especially we indicate how many or how much. Okay. First, we would like to show you how to summarize the categorical data. Okay. For the tables, we use frequency distribution, okay, relative frequency distribution, and percent frequency distribution. For the chart, we use bar chart and pie chart. Okay, so the first three, okay, these are the tables, okay, and the last two, okay, that's the graphical display. Okay, so these five, okay, that's for us to use to summarize the categorical data. Okay, what's the frequency distribution? Okay, the frequency distribution is a table summary of data, okay, and that shows the number of observations in each of the several non-overlapping categories or classes. Okay, so in the table, okay, we have the categories, the number of categories or the number of classes, and the number of classes are non-overlapping. Okay, so the frequency distribution is a table summary, and we summarize the number of observations, okay, or the frequency of observations in each of the non-overlapping classes. Okay, and what's the objective for the frequency distribution? Well, the objective is to provide insights about the data that cannot be quickly obtained by looking only at the original data. Okay, let's see the Miranda Inn example. So we just surveyed 20 guests, okay, and some of them provide below average. Okay, some of them says poor, some of them says average, some of them says above average, and some of them said excellent. Okay, so let's count how many of them, how many of the 20 guests said excellent? Only one. Okay, how many of them said above average? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 of them said above average. Okay, how many of them said average? 1, 2, 3, 4, 5. Okay. How many of them said below average? Okay. 1, 2, 3. Okay. How many of them said poor? 1, 2. Okay. And then we can use a frequency distribution. Okay, this is a table of the frequency distribution. Okay, so according to the Miranda N rating information, okay, we surveyed 20 guests, okay, and then we divide the rating into 5 categories: poor, below average, average, above average, and excellent. Okay, 2 of them said poor, 3 below average, 5 average, 9 above average, 1 excellent. Okay, so this is the frequency distribution. Okay, we can also construct another table that presents the relative frequency and relative frequency distribution. Okay, what's that? The relative frequency of a class is a fraction or proportion of the total number of data items belonging to the class. Okay, so the relative frequency of a class is the frequency of the class divided by the total sample size. Okay, and represents the total number of data. Okay, that's the relative frequency. The other one is the relative frequency distribution. Okay, after that we just have a column and do a calculation to summarize the data that shows the relative frequency for each of the class. Okay, so we have 5 categories, 5 classes. Okay, and then we just divide, okay, each of the frequency, okay, by the total sample size 20. Okay, and then this is the relative frequency. Okay, so 2 of the guests, okay, 2 out of 20 guests said poor. Okay, we divide 2 by 20, and then we obtain 0.10. Okay, that's a relative frequency for poor. Okay, we can also multiply it by 100. So 10% of the 20 guests, okay, just give a poor rating to Miranda N. Okay, and then below average, 3 guests, okay, just rate below average. We divide 3 by 20, which is 0.15. Okay, and then we multiply it by 100%. Okay, 15% of the 20 guests, okay, rate below average. Okay, and then 5 average. We divide 5 by 20, which is 0.25, and multiply it by 100%. Okay, 25% of the 20 guests, okay, give a rating average. Okay, 9 of the 20 guests, okay, rate above average. We divide 9 by 20, which is 0.45. Okay, and multiply it by 100%. That's 45%. So 45% of the 20 guests, okay, that's rate above average for the Miranda N. Okay, only one guest, okay, rate excellent for Miranda N. Okay, we divide 1 by 20, which is 0.05, okay, and multiply it by 100%, which is 5%. 5% of the guests, okay, rate excellent for Miranda N. Okay, so this is the table, okay, that just summarizes the Miranda N rating. Okay, and that, okay, so this table, okay, we display frequency, relative frequency, and percent frequency. Okay, questions? Okay, so that's one way, okay, we use the table to summarize the categorical data. Okay, and then we can use the bar chart to display the categorical data. Okay, so what's the bar chart? It is a graphical display for depicting qualitative data. Okay, and on the horizontal axis, okay, we specify the labels that are used for each of the class. Okay, and on the vertical axis, we display frequency, relative frequency, or percent frequency. Okay, and also we use a bar of fixed width, okay, drawn above each class label, and then we extend the height appropriately. And we should be aware of that all the bars are separated to emphasize the fact that each class is a separate category. Okay. So from the Miranda N frequency, okay, we can use the bar chart. So again, on the horizontal axis, okay, we display the quality rating. And there are 5 classes, okay, poor, below average, average, above average, and excellent. Okay, and on the vertical axis, we present the frequency. Okay, so 2 of the gas, okay, rate poor, 3 below average, okay, and 5 of them rate average, 9 above average, and 1 excellent. Okay, so okay, let's see that all of the 5, okay, all the 5 bars are separated. Okay, all the 5 bars are separated. That's the bar chart. Okay, the other one is the pie chart. Okay, pie chart is a commonly used graphical display for presenting the relative frequency and percent frequency distributions for categorical data. Okay, so first we draw the circle, and then we use the relative frequencies to subdivide the circle into sectors that correspond to the relative frequency for each class. Okay, and because in the circle there are 360 degrees. Okay, a class with a relative frequency, say if it is 0.25, okay, 25%, okay, then we should draw about 0.25 multiplied by 360, which is 90 degrees of the circle, okay, to specify the relative frequency of 25%. Okay. So again, let's use the Miranda N example. Okay. So this is a table that presents the frequency, relative frequency, and degrees of the circle. Okay. So 10% of the 20 gas rate poor. Okay. And then we multiplied it by 360 degrees. Okay. So in the pie chart, about 36 degrees that represent the 10% of the gas that rate poor. Okay. And below average, okay, so 15% of the gas rate below average. We multiplied it by 360 degrees. Okay, 54 degrees. So in the pie chart, about 54 degrees, okay, that accounts for the 15% of the gas that rate below average. Okay. And then average, the relative frequency for average is 25%. Okay, 25% multiplied by 360 degrees, that's 90 degrees. Okay, and then in the pie chart, okay, we use the 90 degrees to specify the category of average. Okay, above average is 45%. Okay, which is about 162 degrees. Okay, so in the pie chart, we use 162 degrees, okay, to specify the 45%, okay, that rate above average. The last one is excellent. Excellent, okay, the class has a relative frequency, which is 0.05. Okay, we multiplied it by 360 degrees, which is 18. Okay, so in a pie chart, we use 18 degrees to specify the 5% that rate excellent. Okay. Okay, so that's the pie chart. Okay, questions? Okay. So from the pie chart, we can say that about 1/2, about 50% of the customers. Hi, are you okay? Are you okay? Okay. Oh, oh, you are not comfortable with the chair. Okay. Okay. So from the pie chart, what can you say? Anything would you like to talk about the pie chart? Okay, so from the pie chart, you can see that about 50% of the customers, okay, they rate excellent and above average, which means about 50% of the guests are satisfied with the, okay, the Miranda Inn quality, okay. But another 50%, okay, they rate poor, below average, and average. Okay, so another 50% might displease the manager. But if we just look at, okay, the other 50%, okay, that rate above average and excellent, this piece of information might please the manager. Okay. Now let's see the first question of today's exercise. Okay, that's from question 3 of chapter 2. Okay, question 3. Okay, this is the question. A questionnaire provides 15 yes, 42 no, and 20 no opinion. Okay. There are 4 questions. In the construction of a pie chart, how many degrees will be in a section of the pie showing the yes? Okay. And how many of them will be in a section of the pie showing the no? Okay. And C asks us to construct a pie chart. Okay. And D asks us to construct a bar chart. Okay, so how many classes? How many classes according to the question context? From the questionnaire? 3, right? 1 is yes. The second one is no. Okay, and third one is no opinion. Okay, so 3 categories. Okay. So according to the question context, how many observations? What's the total number of observations? How many people, okay, do the survey? So 58 plus 42 plus 20, that makes 120, right? Okay. And then, how do we answer question A? In order to find out, okay, how many degrees will be in the section of the pie showing the yes answer? Okay, so in order to answer that, we should divide 58 by 120. Okay, and then we can obtain the relative frequency. Okay, and then we multiply the relative frequency by 360 by 360. Okay, because in order to draw the pie chart, okay, there are 360 degrees in the pie chart. Okay, would you like to do that? Would you like to do that? Would you like to do that on the blackboard? Yeah. Oh, or Jordan, would you like to do that with Adelaide, right? Okay, Adelaide. Okay, so you do that together. Demonstrate together. Both of you. Both of you. You can do it. Are you okay? Yes. Yeah. Oh. Yes. Yes. Yeah. Okay, first we can construct a table that shows the frequency. Okay, and then the third column presents the relative frequency. Okay, so yes, that's 58 over 120. Okay, for no, that's 42 over 120. No opinion, 20 over 120. Okay, that's the second column. Okay, and then the third column. Okay, because we would like to use a pie chart, okay, we need to calculate the degrees in the pie chart. Okay. So for the yes, okay, after we find the relative frequency for the yes group, okay, we multiplied it by 360 degrees. Okay, and then we calculate the degrees, okay, in the pie chart. Okay, the same for no, 42 out of 120, and we multiply it by 360 degrees. Okay, and for the no opinion, okay, 20 out of 120 multiply by 360 degrees. Okay, and then we can use the pie chart, okay, and specify the three categories. Okay. Questions? Are you okay? Okay. 174. It is almost half of the circle. Uh, yeah, yeah, yeah. Yeah. That's yes. That's the yes category. Okay. And then we need to specify the relative frequency. Is it iPhone? No. 58 divided by 120. Oh, that's about 48.33%. Okay, can I use your pen? Yeah, yes. It's about 48.33%. Uh-huh. One. Okay, can I draw? Yeah. Okay, yes. Yes is 174 degrees. Yeah, that's a little bit. Yes, 48.33 degrees. Yeah, oh, we get that from 58 out of 120. Oh, this one. Yeah, 120. you. Keep it. Oh, yeah, frequency. Oh, thank you. Adelaide, are you ready? Would you like to draw the pie chart on the blackboard? Yeah, the pie chart, yes, the pie chart. Yeah, 35%. Uh, in order to make it 100%. Thank you. Oh, oh, also that's no opinion. No opinion. Thank you. Okay. So let's complete the relative frequency and the number of degrees. Okay. Yes is about 48.33. Oh. Um, 0.4833. Okay. 42 out of 120. That's about 0.35. No opinion. 0.1667. Okay. And then let's multiply each of them by 360 degrees. Okay. So after we multiply by 360 degree, okay, this is almost 174, right? 174 degrees. And okay, 0.35. Okay. Now multiply by 360. That's about 126. And this one is 60 degree. Okay. Okay. So according to the table summary, okay, then we can draw the pie chart. Okay. And then we specify, okay, each of them. Pardon me? Oh, oh, there's a lag information. Oh. Okay, but when we use the pie chart, okay, don't forget we should specify the relative percent frequency, okay, for each of the categories. Okay, so about 48.33%. The answer yes. 35% answer no. Okay, the last one is no opinion. Okay, N dot O represents no opinion. Okay, so 48.33%, okay, says yes. 35% says no. Okay. 16.67% say no opinion. Okay, that's the pie chart. Okay, and then the last one is the bar chart. Okay, on the horizontal axis, we present the three classes. Okay, no opinion, no, yes. Okay, and on the vertical axis, we present the frequency for each of the class. Okay, 20 of them. Okay, 20 out of 120. Okay, say no opinion. And 42 out of 120 say no. Okay, 58 said yes. Okay, in the bar chart, okay, all the bars are separated. Okay. Questions? Okay, so this is the first question of today's exercise. Okay, end of chapter question 3. Okay, that's question 3. Okay, so question 8. First question asks us to find, okay, to specify the degrees in a pie chart for the category of yes. Okay, so we should find the total sample size, which is 120. And then we divide 58 by 120, multiply it by 360 degrees. That's 174 degrees. And to answer question B, the degrees, okay, in a pie chart that specify the sector of no. Okay, 42 over 120 times 360 degrees, which is 126 degrees. Okay, question C. Okay, to find the relative frequency, okay, relative percent frequency distribution, okay, for the yes category, 48.3%, or you can use 48.33%. Okay. Okay, and no is 35%. No opinion, 16.7%. Okay. And then we draw the pie chart. And the last one is the bar chart. Okay, we present the frequency for each of the classes, yes, no, opinion, or you can use the other order. Okay, the ascending order is opinion, no, yes. Okay. Questions? Okay. Now, let's see how to summarize the quantitative data. Okay. We usually would use the frequency distribution. Okay, that's also the table summary. Okay, the relative frequency and percent frequency distributions. Okay, also the cumulative distributions. Okay, that's the first three. Okay, are often used to summarize the quantitative data. Okay, in the form of table. Okay, we can also use three charts. The first one is dot plot. The second one is histogram. The third one is the spin and leaf display. Okay. So last time we have visited the Hudson Auto Repair. Okay, the manager of this repair would like to have an understanding about the cost of parts used in the engine tune-ups performed in the shop. And then she collected 50 customer invoices for the tune-ups. Okay, and then let's see the slide that display the 50 tune-up parts cost. Okay, so there are 50 tune-up costs. Okay, first, if we would like to have the frequency distribution, there are 3 steps. Okay, the first one is to determine the number of non-overlapping classes. How many classes, okay, we would like to use. Okay, and then after we determine the number of non-overlapping classes, we determine the width of each class. Okay, for example, in each of the class, how many, okay, what is the interval you would like to cover. Okay, and then we determine the class limit. Okay, Now let's see, what is a good number of non-overlapping classes? Okay, usually we use between 5 and 20. Okay, so the data sets with a larger number of elements usually require a larger number of classes, and smaller one, okay, usually require fewer classes. Okay, and our goal is to use enough classes to show the variation in the data, but not so many classes that some contain only a few data items. Okay. So the guideline for determine the width of each class, that depends upon the classes of equal width. Adley, are you okay? Okay, let's see this one. Okay, how do we determine the class width? Okay, so after we determine the number of classes, okay, now we should worry about the width of each class. Okay, the width of each class that determines the number of values that you would like to put in the interval. Okay, so usually we find the class width. Okay, first we find the difference between the largest data value and the smallest data value, and then divide it by the number of classes. Okay, and then we make the classes the same width, so we can reduce the chance of inappropriate interpretations. Okay, and then in practice, the number of classes and the appropriate class width are determined by trial and error. Okay, and once the possible number of classes is chosen, okay, the appropriate class width is found. Okay, and the process can be repeated for a different number of classes. Okay, then we can use the judgment to determine the combination of the number of classes and class width that provides the best frequency distribution to summarize the data. Okay, and what does the class limit mean? Well, we have to choose the class limit. So each data item belongs to one and only one class. Okay, and usually in a class, okay, we can see the lower class limit and the upper class limit. Okay, so what does a lower class limit identify? It identifies the smallest possible data value assigned to this class. And the upper class limit identifies the largest possible data value assigned to the class. Okay. Also, we have heard open-end class. Okay. It means that it does not require a lower class limit or an upper class limit. Okay, that's what open-end class means. Okay, so let's see the example for the open-end class. So this is the first one. The first class says less than 10. Less than 10. But it does not specify the lower limit of this class. It just says lower than 10. Okay. It specifies the upper limit, but it does not specify the lower limit. Okay. And the last class, it says 40 and above. In this class, it specifies the lower limit, but it does not specify the upper limit. Okay, so this is an example of the open-end class. Okay, because in the first class, lower limit is not given. And in the last class, upper limit is not given. Okay, so both of these classes are open-end classes. Okay, and sometimes we would like to know the class midpoint. Okay, what is the class midpoint? That's a value halfway between the lower and upper class limit. Okay, let's see this one. That's the Hudson Auto Repair example. What's the midpoint for the first class? It specifies the lower limit, which is 50, and the upper limit is 59. So the midpoint should be 55. Yeah, 55. Okay. How about the second one? From 60 to 69. Yeah, 65. Okay. And 75. Okay, that's a midpoint for the third class. 85 for the fourth class. 95 for the fifth class. And 105 for the last class. Okay. So if we choose 6 classes, okay, so the appropriate class width, okay, what does the class width mean? It means how many data values are there in a particular class. Okay, so from the first class, from 50 to 59. Okay, so let's count. 50, 51, 52, 53, 54, 55, 56, 57, 58, 59. So there are 10 data values in this, okay, in this class. Okay, how about the second one? Starting from 60 to 69. Also, there are 10 data values. Okay, the same for 70 through 79, 80 to 89. Okay, 90 to 99. What's that? Okay, so it reminds me that we should have a break right now. Okay, let's have a 10-minute break. Okay, so go back to the Hudson Auto Repair. Okay, we have chosen 6 classes. Okay, 6 classes. And then the maximum value is 109. The minimum is 52. Okay, first we find the difference between maximum and minimum values. Okay, and divide it by the number of classes. Okay, 6. Okay, and then we get a value 9.5. Okay, after that we round it up to the integer, which is 10. Okay, so for each of the classes, each class has 10 data values, and 10 is the class width. Okay, that just specify the number of data values in each of the classes. Okay, so for the first class, there are 10 data values. The second one, 10 data values. Okay, third, 10 data values. Fourth, 10 data values. Okay, fifth, 10 data values. The last one, 10 data values. Okay, so that's how we find the class width. Okay. Then let's see from the relative frequency. Okay, so we have obtained the frequency for each of the class. Okay, then we can go ahead to construct the next 2 columns. Okay, relative frequency and percent frequency. Okay, so how do we find the relative frequency? For the first class, 2 divided by 50. Okay, that's 0.04. Okay, after we multiply it by 100%, that's 4%. Okay, and the second class, 13 out of 50, 0.26. Okay, and then in percentage, that's 26%. The third class, 16. Okay, 16 divided by 50, that's 0.32, 32%. Okay, and then the fourth class, 7 out of 50, which is 0.14. Okay, 14%. From 90 to 99 class, 7 over 50, which is 0.14. Okay, 14%. From 100 to 109, 5 over 50, 0.1, which is 10%. Okay, and then the last row, okay, just gives us the total number of the frequency, total number of the relative frequency. Okay, when we sum up each of the relative frequency, okay, that should be 1. Okay, and after we sum up, okay, each of the class percent frequency, that should be 100%. Okay, questions? Okay, so this is a table, okay, that summarizes the relative frequency and percent frequency distributions. Okay, so what can we gain? Okay, what information do we have from the percent frequency distributions? Okay, how many, what's the percentage of the parts cost in the $50 through $59 class? Okay, from 50 to 59, okay, 4%. Okay, what's the percentage of the parts costs are under $70? Under $70. Okay, under $70. Okay, so the 4% should be counted, right? That's under $70. Okay, and also from $60 to $69, okay, 26% should be counted. Okay, so both of them are under $70. Okay, so we add them up, that's 30%. Okay, that's 30% of the parts costs are under $70. Okay, the greatest percentage of the parts costs are in the $70 through $79 class. What's the percentage? And it is almost, okay. Okay, that's 32%. 32% is almost 1/3. 1/3 of the whole sample. Okay. Then okay, what is the percentage of the parts cost are $100 or more? $100 or more. Okay, $100 or more, that's in the last class, from 100 to 109, which is 10%. Okay. Okay, so given a table summary, okay, that summarize, okay, the frequency, relative frequency and percent frequency, okay. These are the questions, okay, that might ask us during the quiz or exams, okay. Okay, also, when we summarize the quantitative data, we use the cumulative distribution. What's that? Okay, a cumulative frequency distribution shows the number of items with values less than or equal to the upper limit of each class. Okay, and from the cumulative frequency distribution, we also calculate the cumulative relative frequency distribution. What's that? It shows the proportion of items with values less than or equal to the upper limit of each class. Okay, and then finally we construct a column that represents the cumulative percent frequency distribution, which shows the percentage of items with values less than or equal to the upper limit of each class. Okay, so cumulative distribution, okay, just summarize the number of items with values less than or equal to the upper limit of each class. Okay, so again, the last entry in a cumulative frequency distribution should be equal to the total number of observations. Okay, and when we count the cumulative relative frequency, okay, distribution, the last entry of that should equal 1. And the cumulative percent frequency distribution, the last entry should be 100. Okay, this is the tune-up cost, okay, for Hudson Auto. Okay. So from this table, okay, if we would like to construct columns to describe the cumulative frequency, cumulative relative frequency, and cumulative percent frequency, okay, the first column, okay, should be, we just write down the upper limit for each of the class. Okay, so for the first class, the upper limit is 59. Okay, so we just write down the upper limit, okay, 59, lower than or equal to, okay, which is 2. Okay, 2 of land, 2 out of 50. Okay, they just spend, okay, between $50 to $59. Okay, the cumulative frequency is 2. Cumulative relative frequency is 2 out of 50, which is 0.04. Okay, multiply it by 100%, that's 4%. Okay, the second column, okay, in the second column, the upper limit is $69. Okay, and this one, okay, we report anything, any data values, okay, lower than or equal to $69. Okay, so we should add 2 to 13. Okay, questions? Okay, so the cumulative frequency for the second class, okay, anything under $69, that's 15. Okay, and then the cumulative relative frequency is 15 over 50, that's 0.3. Okay, and multiply it by 100%, 30%. Okay, and then the third class, the upper limit of the third class is $79. Okay, and then we should report, okay, the cumulative frequency, any data values, okay, under $79. So we should add 2, okay, to 13 to 16. Okay, we add them up, that's 31. Okay, and then we divide it by 50.62. Okay, in percentage, that's 62%. Okay, And then the fourth column, okay, the fourth class. In the fourth class, the upper limit is $89. Okay, anything, okay, all the tune-up costs, okay, all the 50 tune-up costs, okay, are under $89. Okay, should be 2, also 13, 16, and 7. We add them up. That's okay, 38. Okay, that's the cumulative frequency for this, okay, for this entry, okay, below or, yeah, that's lower than or equal to $89, which is 38. Okay, and then we divide it by 50.76, which is 76%. Okay. And in the fifth column, the fifth class, the upper limit is $99. Okay, $99. All the values, okay, under $99. Okay, so 2 is included, 13 is included, 16, 7, and 7. So we add them up, which is 45. Okay, and then we divide it by 50.9, 90%. The last entry, okay. In the last class, the upper limit is 109. Okay, so we should report all the costs under $109. Okay, so we add all of them up. That should be 50. Okay, 50 over 50, that's 1. Okay, so again, the last entry for the cumulative frequency should be equal to the number of the total value. Okay, and the cumulative relative frequency, the last entry should be 1. Okay, and the cumulative percent frequency, the last entry should be 100%. Okay, questions? Okay, now let's see the second question of today's exercise. Okay, the following are the duration in minutes of a sample of long-distance phone calls made within the continental United States reported by one long-distance carrier. Okay, so there are 7 classes. Okay, 0 but less than 5. The relative frequency is 0.37. 5 but less than 10, 0.22. Okay, 10 but less than 15. Okay, 0.15. Okay, 15 but less than 20, 0.1. 20 but less than 25, 0.07. 25 but less than 30, 0.07. 30 or more, 0.02. Okay, so let me ask you one question. Okay, what is the class width? The class width in each of the class. What is the number of data value in each class? In the first class, 0 but less than 5. Less than 5, so 5 is not counted. So we start from 0, 1, 2, 3, 4. Okay, that's 5. Okay, 5 minutes. Okay, for the first class width. How about the second one? 5, 6, 7, 8, 9. Okay, 10 is not included, so 5. Okay, how about the third one? 5. Okay, 15 but less than 20. 5. Okay, 20 but less than 25. 5. Okay, 25 but less than 30. 5. Okay, the last one, 30 or more. Well, we don't know because this is open-end class. Okay, there is no upper limit. Okay, in this table, we only have information about the relative frequency, but we have no information about the frequency. Okay, no frequency. Okay, so now let's see the questions. What is the width of each class? 5 minutes. Okay. The second question, if 10 calls lasted 30 minutes or more, how many calls lasted less than 5 minutes? Okay. It says if 10 calls lasted 30 minutes or more. That's the last entry, the last class. Okay. Okay, so now it gives us the frequency for this particular class, which is 10. Okay. Okay, the second question says that, okay, 10 calls, okay, lasted longer than 30 minutes. Okay, so now it gives us the information about the frequency, okay, for the last class, which is 10. Okay, so here comes the question. How do we obtain the relative frequency 0.02? Yeah, so 10, so yeah, so we divide 10 by the, okay, the sample size, okay, and then that's 0.02, okay, so that's how we find 0.02, the relative frequency for the last class. Okay, so 10 divided by sample size, 0.02. Okay, so that's fine. The total sample size. Okay, so that's 10 divided by 0.02. What's that? 500, yes. Okay, so now we have obtained the total sample size, which is 500. Okay, so now we can go ahead, okay, to obtain the information of frequency for each of the class. Okay, questions? Oh, it's here. That's from the question. Okay, it says if 10 calls lasted 30 minutes or more, how many calls lasted less than 5 minutes? Okay, so it asks us to find the frequency for the first class. Okay, so how do we get the frequency for the first class? Okay, so to find that, we should multiply 500 by 0.37. Okay. Which is 185. Okay. Okay, so we have answered the second question. Okay. Then, what is the cumulative relative frequency for the percentage of calls that lasted under 20 minutes? Under 20 minutes. Okay, so to answer question 3, okay, we will need to, okay, yeah, add up all the relative frequency under 20 minutes. Under 20 minutes. Okay, so under 20 minutes, we should add up the relative frequency for the first four classes. Okay, starting from less than 5, which is 0.37. Okay, from 5 to less than 10, 0.22. From 10 to less than 15, 0.15. From 15 to less than 20, 0.10. .84. Questions? Okay, so this is the second question of today's exercise. Jordan, could you please take a picture of that? Oh, okay. Any questions? Oh. Okay, the other way to answer question 3, okay, because it asks us to find the cumulative relative frequency for the percentage of calls that lasted under 20 minutes. Okay, the other way is, we deduct 0.02, 0.07, 0.07 from 1. That's another way to find 0.84. Okay. That's the first way we add up the 4 relative frequency, okay, for the first 4 classes. The other way is because in the cumulative relative frequency distribution, the last entry should be 1. Okay, so to find the cumulative relative frequency, okay, under 20 minutes, the other way is we deduct 0.02. Okay. Deduct 0.07. Deduct 0.07 from 1. Okay. And this way can also obtain the same answer, 0.84. Okay. The second way is we deduct the relative frequency, okay, for this class, okay, from 20 minutes to less than 25 minutes. Okay, the relative frequency 0.07. That's the class from 25 minutes to less than 30 minutes. And also we deduct 0.02. That's the relative frequency for the last class, which is equal to or longer than 30 minutes. Okay, so we deduct this 3 relative frequency, from 1. That can help us to find the cumulative relative frequency, under 20 minutes. Okay. Questions? Oh, number 2, it's here, 185. Yeah. First, we find the total sample size, and then that's 500, and then we multiply it by the relative frequency. Okay, less than 5 minutes. That's how we find the frequency for the first class. KB? KBK has questions. Okay. Jordan and Hibiki asked us the question. Okay. When do we use the formula, okay, to find the class width? Okay. From here, could you please help me to find the minimum value from the 52 knob invoices? What's the minimum value and what is the maximum value? Okay, so in the first line, we found 52 and 52, 57 and 52. Okay, so 52 is the smallest, okay, in the first row. How about the second row? Can we find any values that is under 52? No. How about the third? No. Fourth? No. Okay, how about the last one? No. So 52 is the minimum value. Okay. Let's find the maximum. Okay. Maximum. 109. Okay, so you have found it, which is here. Okay. 109. Okay. And then if we determine 6 classes, okay, if we would like to determine the number of classes, 6, okay, then we can use the formula, okay, to find the class width, okay, which is maximum value, okay, and we deduct minimum from the maximum. So 109 minus 52. Okay, and divided by 6. Okay, so that's about 57 over 6. It is almost 9.5. Okay, and then we round it up to integer, which is 10. Okay, so that's how we find the class width. Okay, if we are faced with a question like that in an exam, then we of course need to apply. Okay, we need to use this formula to find the class width. Okay, first we should find the maximum and minimum values, from the 52 knob costs. Okay, so we find the minimum value $52, maximum is $109. Okay, suppose that the question says the number of class is 6. Okay, and then it asks us to find the class width. Okay, so we first find the difference between minimum and maximum. Okay, and divide it by the number of class, 6. Okay, and which is 9.5. Okay, we round it up to the most integer, which is 10. The question says, the question context says, okay, they have already determined 6. Yeah, it's here. Yeah, they're already chosen. Okay, they have chosen 6. Okay, and then that's how we find the class width. Okay. Questions? Okay, so to summarize the quantitative data, okay, we use the relative frequency, okay, percent frequency, okay, cumulative frequency, okay. So what are the charts that we use to summarize the quantitative data? One of them is dot plot, okay. Dot plot is the simplest graphical summaries of data, okay. In the dot plot, the horizontal axis shows the range of data values. Okay. Then each data value is represented by the dot placed above the axis. Okay. So from the Hudson Auto Repair, okay, 50 tune-up parts costs. Okay. We can use the dot plot. Okay. The horizontal axis, okay, presents, okay, from 50 to 60, okay, 70, 80, 90, 100, and 110, okay. And then we can, okay, draw the dot to specify the parts cost. Okay, the smallest value is 52. Okay, we draw it here. Then 57. Okay, it is around here. Okay, and then 362. Okay, 362. Oh, sorry, 462. Okay, 165, 166, and 167. Okay, 368, 369. Okay, and then 271, 272, 173, 274, okay, 375, 166, 76, 177, okay, 178, 379, 280, 182, 183, 185, okay, 187, 188, okay, 191, 193, okay, 497, 199, okay, and 101, okay, 104, 105, 109, okay. So that's the dot plot. Help us to, okay, summarize the Hudson Auto Repair. Okay. So from the dot plot, as you can see that, okay, most of the customers, when they visit Hudson Auto Repair, they might have to spend, okay, between $70 to $79. Okay, most of the customers, they have to spend between $70, okay, to and $79. Okay. And another chart is called histogram. Okay, histogram is very similar to bar chart, but they are different. Okay, in the histogram, okay, we draw a rectangle, okay, above each class interval, okay, with its height corresponding to the interval's frequency, relative frequency, or percent frequency. Okay, but in the histogram, all the rectangles are adjacent to each other. But in the bar chart, the bars are separate. Okay, let's see the histogram. if we draw the histogram for the tune-up cards cost, as you can see that, okay, we divide the part cost into 6 classes. Okay, so there are 6 classes, and for each of the class, we draw the rectangle, okay, and the height corresponds to the frequency. Okay, so from 50 to 59, okay, the frequency is 2. From 60 to 69, the frequency is 13. From 70 to 79, the frequency is 16. Okay, from 80 to 89, the frequency is 7. The same for 90 through 99. Okay, and in the last class, from 100 to 110, okay, the frequency is 5. Okay, so in the histogram, all the bars are adjacent to each other, but in the bar chart, remember in the bar chart, okay, the bars are separated. This is the bar chart. But in the histogram, all the bars are, okay, adjacent. Also, the histogram shows skewness. Okay, that's the distribution of the values. Okay, what does symmetric mean? Symmetric means that, okay, the left tail is a mirror image of the right tail. Okay, so the right tail and left tail, they are mirrored. Okay, that's symmetric. The height of people, okay, that shows the symmetric. Okay, the exam scores, okay, the exam scores shows us that the left tail is longer than the right tail. Okay, so we say that the exam scores are moderately skewed left because, okay, the scores have a longer left tail than the right tail. So it is moderately skewed left. How about this one? The housing values. The housing values, as you can see that the right tail is longer than the left tail. Okay, so we say that the housing values are moderately right skewed. Okay. How about this one? The executive salaries. The salaries have a way longer right tail than the left tail. So we say that, well, the salaries have a very long tail to the right. It is highly skewed right. Okay, so we can use the histogram, okay, to show the skewness. Okay, questions? Any questions? Okay, let's see the last one. The last chart we use to, okay, summarize the quantitative table, quantitative data. Okay, STEAM and leaf display. Well, it shows both the rank order and shape of a distribution of data. Okay, it is similar to the histogram on its side, but it has the advantage of showing the actual data values. And the leading digit of each data item are arranged to the left of a vertical line. Okay, and to the right of the vertical line, we record the last digit for each item in a rank order. Okay, and each line in the display is referred to as a stem. Each digit on the stem is a leaf. Okay, so let's see the Hudson Auto Repair. Okay, here are 50 tune-up costs. Okay, so we draw the vertical line, okay, and then we identify each of the leading digits. Okay, so we have from 50 to 59. Okay, so we'll put 5 here. From 60 to 69, 6. From 70 to 79, we'll put 7 here. From 80 to 89, okay, we'll put 8 here. From 90 to 99, we'll put 9 here. From 100 to 109, okay, we'll put 10 here. So in the string, okay, we put 5, 6, 7, 8, 9, 10. Okay. And then on the right side, okay, to the vertical line, we put leaf. Okay. For example, okay, there are 52, okay, 152 and 157 here. Okay, so we put 52, 57. Okay, how about 6? Okay, so as you can see that there are 462, 165, 166, 167, 368, 369. Okay. From 70 to 79. Okay. There are 271, 272, 173, 274, 375, 176, 177, 178, 379. From 80 to 89, 280, 182, 183, 185, 188, 189. From 90 to 99, okay, 191, 193, 397, 198, 199. Okay, from 100 to 109. Okay, we have 101, 104, 105, 1109. Okay, so that's the stem and leaf display. Okay, to summarize, okay, the quantitative data. Another way to summarize the stem and leaf display, okay, we can use this. Okay, so we put, okay, two, okay, so if we divide the 50, okay, into, okay, from 50 to 54, from 55 to 59, okay, so the first one we put 2 here, and the second one we put 7 here, okay, and the same for 6. Okay, so there are 462. Okay, they are from 60 to 64. Okay, and the other numbers, okay, 65, 66, 67, okay, 68, and 69. They are belong to, okay, 65, 69. Okay, and then, okay, for the 70, okay, 71, 72, 73, 74. Okay, they are in the category from 70 to 74. Okay, the rest of them, 75, 76, 77, 78, 79, they are belong to the next one. Okay, from 75 to 79. Okay, and then from 80s, okay, we put 0023 in the category, okay, from 80 to 84, and then 589, okay, in the category 85 to 89. 90s, we put 1 and 3 in the category from 90 to 94. Okay, 7, 7, 7, 8, 9. Okay, that's in the category from 95 to 99. Okay, and then from 100 to 104, we put 1 and 4. From 105 to 109, okay, we put 5, 5, and 9. Okay, questions? Okay, let's take another 10-minute break. Okay, and in the next session, I will take attendance. Okay, so have your cell phone ready. Okay. Okay, so now let me check attendance for you. Okay. Oh, you cannot scan. Oh, just check 美心、吉川萌乃、包凤璇、吉泽野野风、和田彩爱、张爱玲、内田祥嗣、拥有侧大、艾迪恩、秋叶航程。哦，OK，谢思成、谢耀善、艾伟文、赖宏尔、蔡耀威、吴太惠、庄庆红。OK。Oh, so is Choye Hansen still in Japan or in quarantine? Oh, okay. On 23rd. Oh. Oh, so next Tuesday I will see him in class. Okay. Oh, good. Please tell him that I say hi. Okay. Oh, his name is Kose. Kose. Oh. Okay. Now let's see. So we have learned stem and leaf display. Okay. In the leaf unit, a single digit is used to define each leaf. And in the preceding example, the leaf unit was 1. Okay. But the leaf unit could be 100, 10, 1, 0.1. Okay, the leaf units may be 100, 10, 1, 0.1, and so on. And the leaf unit, okay, when the leaf unit is not shown, it's assumed to be equal to 1, okay? And the leaf unit indicates how to multiply the stem and leaf numbers in order to approximate the original data. Okay, let's see this example. If we have data with values such as 8.6, 11.7, 9.4, 9.1, 10.2, 11.0, 8.8. Okay, if we use leaf unit as 0.1, okay, leaf unit is 0.1. Then, okay, we draw the vertical line, okay, to the left of the vertical line, that's the stem, okay, 8, 9, 10, 11, okay, and then, okay, in the 8, we have 8.6, okay, so we put 6 here, 8.8, oh, sorry, 8 here, okay, 9.1, so we put 1 here, 9.4, 4 here, okay, 10, we have a 10.2, okay, 11, we have 11.1, 11.7, so we put 0 and 7 here, okay. In this example, okay, we have values such as 1806, 1717, 1974, 1791, 1682, 1910, 1838. Okay, the leaf unit represents 10. Okay, so we draw the vertical line to the left of the vertical line. Are you okay? Okay, so we put 16, 17, 18, and 19. Okay. Okay, so we have a 1682 here because each leaf unit represents 10. Okay. Instead of putting 182 here, we just put 8. Okay, so we round up. Okay, 82. Actually, in this case, we round it down to 80. Okay, and then 1717. Okay, we round it down to 10. Okay, and then 1791. Okay, we round it down to 90. So we put 1 and 9 here. Okay, 1809. Okay, we round it down to 0. Okay, so 1800, put 0 here. Okay, and the other one, 1838. We put 3 here. Okay, 1910. So we put 1 here. Okay, and the last one, 1974. We put 7 here. Okay, questions? Okay, another chart is called Pareto diagram. Okay, usually we draw this Pareto diagram used for quality control. Okay, and the bar charts are used to identify the most important causes of problems. Okay, and the bars are arranged in descending order, okay, of height from left to right. Okay, so, and in each of the bars, okay, in the middle, we depict the cumulative frequency, okay, distribution. Let's see the Miranda N example. Okay, we have poor, below average, average, above average, and excellent. And also we construct the table, okay, and we highlight the frequency, relative frequency, and percent frequency. Okay, and then we add one more column. Okay, that's the cumulative percent frequency. Okay, so again, the last entry, okay, of the cumulative percent frequency should be 100%. Okay, and then remember when we draw the Pareto chart, Pareto diagram, each of the rectangle should be in a descending order. Okay, so let's see which one has the most relative frequency. Which class? Okay, above average, and then average. Okay, the third is below average, and then poor. The last one is excellent. Okay, so we should put the class in a descending order. Okay, and then in each of the class, we draw the cumulative percent frequency. Okay, so in a above average, okay, the cumulative percent frequency is 45%. Okay, so in the middle, we put 45%. Okay, and that corresponds to the right, okay, vertical axis. The right vertical axis presents the cumulative frequency. Okay, cumulative percent frequency. And then the average, in the average, the cumulative percent frequency is 70%. So, okay, we find the 70%, okay, corresponds to the right vertical axis. Okay, in the middle of the average, okay, we depict 70%. Then below average, the cumulative percent frequency is 85%. Okay, so we find the 85%, okay, corresponds to the right vertical axis, okay, in the middle of the below average. Okay, poor, 95%. Okay, so in the poor, in the middle, okay, we depict the 95%, okay, corresponding to the right vertical axis. And then excellent, okay, that's the last entry. And the cumulative percent frequency should be 100%. Okay, so this is the Pareto chart of Miranda N quality ratings. Okay, questions? Usually, okay, we should present this Pareto chart for the manager in order for him or her to do the quality control. Okay, questions? Okay, so now let's see the last topic of the chapter 2. We use the tables and charts to display, to summarize two data. Okay, we can summarize data for two variables, okay, by using tables or charts. Okay, and also the data visualization, that's the best practice in creating effective graphical displays. Okay, so far we have focused on methods to summarize data for one variable. But if we would like to, okay, summarize the relationship between two categorical variables or two numerical variables, or one categorical variable and the other one is quantitative variable, okay, what should we do? Okay, we can also use the cross tabulation table or use chart, okay, to display the relationship between the two variables. Okay, the table is called cross tabulation, or the other name for the table is contingency table. Okay, this table is a tabular summary for data for two variables. Okay, when one is categorical and the other one is numerical, or when both are categorical, or when both are quantitative. Okay, and the left and the top margin labels define the classes for the two variables. For example, we are interested in the Finger Lakes homes. Okay, we would like to purchase a home. Okay, what's the price? Some of them are purchased, okay, below $250,000. Some of them, okay, are purchased at above $250,000. Okay, so this is a cross tabulation table. Okay, it just describes the relationship between two variables. Okay, one of them is, we can, okay, classify the home style into four categories: colonial, log, split, A-frame. Okay, and the other variable is price range. That's numerical variable. Okay, and then we specify, okay, the price range below $250,000 or above $250,000. Okay, and the total sample size is 100. Okay, so out of the 100 homes, okay, 55 of them are priced below $250,000. 45 of them are priced above $250,000. Okay, and out of the 100 homes, 30 of them are colonial, 20 of them are log, 35 of them are split, 15 of them are A-frame. Okay, so what are the insights we can obtain from the cost tabulation table? What's the greatest number of homes? The greatest number of homes. Okay, that's 19. Okay, so most of the people purchased split home style, okay, and at the price below $250,000. What is the least? Yeah, 3. Okay, 3 of them purchased A-frame at the price above $250,000. Okay. We can also convert the entries in the table into row percentage or column percentage. Okay, so that way can provide additional insight about the relationship between the home style and the price range. Let's see, if we convert this original table into row percentage, what do we do? Okay, we divide 80 by 55. Okay, that's how we get 32.73% here. Okay, and we divide 12 by 45. Okay, that's how we get 26.67% here. Okay, 10.91. How do we get that? 6 over 55. Okay, 31.11. 14 over 45. Okay, how do we interpret 26.67% here? What does that mean? Okay, after we divide 12 by 45, that's 26.67%. So we say that, okay, so 26.67%, okay, of the colonial home, okay, are priced above $250,000. Okay, or we say, sorry, I should say that. Okay, for home price above $250,000, okay, 26.67% of them are colonial. Okay, so for home price above $250,000, 31.11% of them are log. Okay, and for home price below $250,000, 32.73% of them are colonial. Okay, that's the way, okay, we just convert the original table into row percentage. Okay, we can also, okay, convert the original table into the column percentage. Okay, how do we get 60%? We divide 18 by 30, okay, and multiply by 100%, that's 60%. Okay, and 40% is 12 over 30, multiply by 100%. Okay, how about 30%? 6 over 20, multiply by 100%. And then 70%, 14 over 20, okay, multiply by 100%. Okay, how do we interpret 40%? Okay, in this case, we should focus on column. Okay, so for the home, okay, so for the homeowners, if they purchase colonial, okay, 40% of land okay, have the home price above $250,000. Okay, and that's above $250,000. Okay, if we purchase log home, okay, 30% of land, okay, 30% of land are below $250,000. Okay, questions? Okay, let's see another example, 400 sample invoices. Okay, this is the original table. Okay, we can convert all the data values into overall total. Okay, so that is, we divide 170 by the total sample size, which is 400. Okay, and then we obtain 42.50%. Okay, and then 20 divided by 400, which is 5%. 190 divided by 400, okay, 47.5%. Okay, so now let's see these two, okay, that I circle with red. Okay, what do they mean? Okay, one of them is, okay, the small amount, okay, the total 47.50%. The other one, okay, no arrows, 83.75%. Okay, so we say that, okay, 83.75% of the sample invoices have no errors. Okay, and 47.50% of the invoices are small amount. Okay, and 16.25% of the invoices have errors. 35% of the invoices are median amount. Okay, that's the original table. After we convert it into raw total, okay, according to raw total, so how do we get 89.47%? We divide 170 by 190. Okay, that's how we get 89.47%. Okay, and then we divide 100 by 140. Okay, 71.43%. Okay, and then 65 over 70, 92.86%. Okay, let's see these three. Okay, these three values. How do we interpret that? Okay, let's see the first one. Okay, so for the median invoices, okay, the median invoices, okay, 28.57 of land have errors. And then for the small amount invoices, 10.53 of land have errors. For the large amount invoices, 7.14% of land have errors. Okay, so we can compare, okay, between the three. And we conclude that, okay, for the median amount invoices, okay, it has a larger chance to have errors than the small amount invoices or the larger amount invoices. Okay, questions? Okay. That's the cross tabulation. Okay, after conversion, okay, we convert it into column total. Okay, so how do we get 50.75%? We divide 170 by 335. Okay, that's how we get 50.75%. Okay, and 30.77% is 20 over 65. Okay, now let's see 61.54%. How do we interpret that? Well, for the invoices that have errors, okay, there is a 61.54% of land are median amount. Okay, questions? Okay, let's see. But sometimes when we construct a cross tabulation table, we might encounter Simpson paradox. Okay, what's that? In some cases, the conclusion based upon the aggregated cross tabulation can be completely reversed if we look at the unaggregated data. And the reversal of conclusion based upon aggregate and unaggregated data is called Simpson's paradox. For example, from the UC Berkeley gender bias, from this table, we might conclude that men's admitted rate is higher than women's, based upon the table. If we divide the admission application based upon gender, men and women, then we have this conclusion: men applying were more likely than women to be admitted. But if we examine the individual department, 6 individual department, and also we look at men and women, what conclusions can we draw from this table if we just look at individual department? In department A, it seems that male students are likely to apply for department A, and their admitted rate is high. And department C, most women, most female students would like to apply for department C, and their admitted rate is 34%. So according to the individual departments information, we can conclude that women tended to apply to competitive departments with low rates of admission, whereas for male students, they tended to apply to less competitive departments with high rates of admission. So this is a Simpson's paradox. When we look at unaggregated data, and aggregated data, we have opposite conclusions. So this is called Simpson's paradox. Questions? The last question of today's exercise, that's from last two, sorry. You have collected data on the responses to 2 questions, asked in a survey of 40 college students majoring in business. What's your gender? What is your major? Which of the following is the best for presenting the data? So we would like to use a table, or a chart to describe the relationship between gender and major. 2 variables. And these 2 variables, both of them are categorical variables. So which one? If we would like to use table, or chart, which one should we use to describe the relationship between the 2 variables? So cross-tabular table, cross-tabulation table. So this is the last 2 questions. Jordan, could you please take a picture of that? Let's see the last question. Question 32. End of question, chapter 2. 32. No, exercise. So there are 5 sub-questions. A, compute the row percentage. Okay, so this is the original table. Okay, there are two variables. One is the region. The other one is the income level of households. So we use the cross tabulation table to describe the relationship between region and income level. Okay, so question A asks us to compute the row percentage and identify the percent frequency distribution of income for households in each region. So question A asks us to convert the table into row percentage. B, what percentage of households in the West region have an income level of $50,000 or more? And what percentage of households in the South region have an income level of $50,000 or more? Okay, so these are two different questions. Okay, the first one is, okay, we already conditioned the income level, and it asks us about the percentage of households, okay, in the West region. The other one, okay, is the percentage of households in the South region that have income level of $50,000 or more. Okay, so one is from West region, the other one is South region. Okay, C, construct percent frequency histogram. Okay, so C asks us to construct the histogram, okay, for each region of the households. Do any relationships between regions and income level appear to be evident in your findings? Okay, so after we construct the histogram, okay, the question asks us to, okay, find the relationship. Okay, D, compute the column percentage. Okay, so we convert the original table into column total. And question E, what percent of households with a household income of $100,000 and over are from the South region? And what percentage of households from the South region have a household income of $100,000 and over? Okay, what are the two percentages different? Okay, so this is your last question of today's exercise. Okay, so no homework today, but we have, okay, we have a little bit, okay, a little bit complex, okay, conflicting question.
For the instructor, we have to make 4 row percentages,
Mm,
like
for,
4 bar graph.
for part E, part A.
On the row percentage, and then like contrast
Yes,
so we have like you have to make like one graph for northeast, one graph for east west, one graph for south, one graph for like
yeah, so four regions.
sorry, 4 of these. 1, 2, 3, 4.
Yes, yeah. Okay. Okay, let's work on part A together. Okay, row percentage. So we should convert the original data into row percentage. Oh, Jordan, could you please take a picture of that? Okay. Oh, you already did. Oh, thank you. Okay, so let's work on part A together. Um, first we should compute the row percentage. Okay. And then we should draw 4 charts. Okay, 4 charts. Okay, identify the percentage. Oh, sorry. We can also use the table to identify the percent frequency distribution. Okay, of income for household for Northeast, for Midwest, South, and West. So probably we need five students to do that. Okay. Lovely. Lovely. Could you please compute the row percentage? Okay, so convert the original table into row percentage. Okay. Momoka, could you please identify the percent frequency distribution of income for household in Northeast? After we, you already did that? Okay, thank you. So after we convert the original table into row percentage, and then we identify the percent frequency distribution for Northeast. So you will take care of Northeast. Yeah. And I forgot your name. Oh, Jovita. Okay, you take care of Midwest. Okay. And 彩爱 will take care of South region. And Michael will take care of West. Well, this is the table I would like for Lovely to do. Okay, that's for Lovely, the row percentage. And then Momoka will take care of the northeast. Oh, Momoka, no, oh, Momoka, no, no. Okay, and then Jovita will take care of Midwest. Oh, Chai will do South, and Michael will do West. Okay. Any questions? Yeah, just frequency. Yeah, relative frequency in percentage. Yeah. So for example, no, northeast. For northeast, so under $15,000. Oh, 15. Under 15. And then you will provide us the percent frequency. Yeah, percent frequency. Yeah, what's the percent frequency for under $15,000 and yeah, 15 to 24,999. Okay, and 25,000 to 34,999, and 35 to 49,999, 50,000 74,999, and 75 to 99,999, and 100 and more. Uh-huh. Okay, so Nonoka will do that for Northeast, okay, and Jovita will do Midwest.
All I have to do is I just have to divide each one with the total
Yes,
and then change to the percentage.
yes, yeah, change to the percentage. Yes. Uh, Tsai will do South. Michael will do West. And Lovely will, yeah, will convert all the values into, yeah, based upon the raw percentage. Yes.
A, right?
Yeah, A.
Then what is Jovita?
Oh, yeah. So what you do is you convert all the numbers based upon the raw total, and then Jovita will do is okay. She will focus on the Midwest region, and then that's she will write down okay the percent frequency for each of the classes. Okay, so actually you can do that together because yeah, you can do that together because you base upon the yeah you need to do the conversion based upon the raw total. But each of you take care of different region. Mm. You can help her. You can help her. pass the information to Lovely. You're welcome. Wow. Because I, yeah, I'm almost running out of time. Okay, you don't have homework to do this week, but you have exercise. So let me change the deadline for the homework.
So we can submit the exercises like tomorrow or
Oh, Friday. Also Friday before the discussion class. Yeah, before the TA session.
but we don't have any homework.
No homework.
We submitted the exercise.
Yeah, yeah, just exercise. Okay. Let me change the. Uh, more. Okay, let me check with Jordan. Jordan, how many questions for today's exercise? How many? Okay, so I have changed the deadline. I have changed the deadline for today's homework. Okay, so you just submit your exercise, only exercise by Friday before the TA session. Okay. Oh. Okay. You can take a picture of question A. Okay. So after conversion, okay, based upon the raw percentage. Okay, so this is the table. Okay, so each of the value are percentage. Okay, and then okay, for the west region, west region. Okay, I would like for you to present the percent frequency distribution like this way, okay, for the west region, okay, and for south, for Midwest and Northeast, okay. Okay, so that's question A. Okay, this is question A. Okay, first we convert all the table into raw, okay, raw total, and this is the table, okay, and after that we present the okay the percent frequency for the four, okay, for four regions. Okay, this one is for west region. Yeah, that's west. Okay. Oh, Michael has done that, right? Okay. Okay. Okay, you have a good day. I will see you. Oh, this one? Yeah, that's yeah, because the second okay, let's go back to the question A. Okay, A asks us to compute the row percentage, and after that, identify the percent frequency distribution for each region. And because there are 4 regions, so we need to present, okay. Yeah, so this is for West region. We also do that, okay, do the same thing. Yeah, for South, for Midwest, for Northeast. Yes, yeah.
Can we just make the bump one, like the graph bump, one by one?
Oh, yeah. Oh, you can do that like this one. Okay. So, uh, the first column presents the class, and then the second one, that's northeast percent frequency. Okay. And then the third column is Midwest percent frequency, and south percent frequency, west percent frequency. You can do that. Okay, you can do that. Question? Oh, oh, great. Bye, Adley. Bye. Bye, Hibiki. Bye. You have a good day. Oh, TA is here. Oh.